The last example illustrated the idea behind compound interest. We actually have a formula that allows us to determine the future value of an amount compounded n times in a year after t years. So we don't have to go through the process of computing the interest at each step or at each point when interest is paid. Let's look at an example. Investing $1,000 at an annual rate of 10% compounded annually, quarterly, monthly, and daily will yield the following amounts after 1 year. So what we're going to do in this problem is use the compound formula. We have A, the future value, is going to equal P, the present value, or the deposit, times 1 plus R, where R is the annual interest rate in a decimal, divided by N, where N is the number of compounding periods in the year, raised to the N times T power, where T is the amount of time in years. So in this particular example, T is equal to 1, because we're only looking at 1 year worth of interest. So suppose we were compounding annually. If we're compounding annually, the future value A is going to be equal to the present value of $1,000, the amount deposited, times 1 plus the annual interest rate is 10%. Remember, we expressed that as a decimal, and we're compounding annually. So there's only one compounding period in the year, and so we divide the interest rate by 1 and then raise to the 1, technically 1 times 1 power, because t is 1 year. So if we work this out, we get 1,000 times 1.1. 1,000 times 1.1 is $1,100. Now suppose that we compound quarterly. If we compound quarterly, that means that we're earning interest 4 times in the year. If I earn interest 4 times in the year, then my value of N is going to be 4. So I have the future value A is equal to $1,000 times 1 plus 0.10 divided by 4 raised to the 4th power. If I work this out, I get $1,103.81. How about compounded monthly? If I compound monthly, that means that my value of N is equal to 12 because I'm earning interest 12 times during the year. So again, I have a future value A is $1,000 times 1 plus 0.10, this time divided by 12, again compounding monthly, raised to the 12th power. If I work this out, I get $1,104.71. Finally, let's do compounding daily. If I do compounding daily, then the value of N is 365. I get $1,000 times 1 plus 0.10 divided by 365 raised to the 365 power. If I work this out, I get $1,105.16. What should you have noticed? You should have noticed that as the number of compounding periods increase, the value of the account also increases, all other things equal. So it's in your best interest to have interest paid as often as possible. This should be an apparent result because the more often I'm paid interest, the more often that interest has time to earn itself interest.